Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 14. We're going to talk about fractions again.
No.
Oh boy.
Alright, fractions are the spawn of Satan.
Can I go to the bathroom real quick?
No.
Yes. So numerator
just wants to
over
skip out on the hard part.
denominator. So the numerator is the number on top. The denominator is the number on the bottom. What's that thing in the middle called?
A line.
It's a line, but we call it the fraction bar.
If it's a bar,
Guys,
then
only
why
10%.
doesn't it?
It also means the out of.
If it's the out of, then why
It's
is it
the
a
out
line?
of bar. Okay? The out of bar. So if you have like 3/4, you could say this is 3 out of 4 total pieces, right? If I ate 3/4 of the pizza and there were 4 pieces, then I ate 3 out of 4.
Then there'd be one left. We get it.
Okay? So you can think of that fraction bar as the words out of. So 3 out of 4. It was pizza night last night. And we got to make our own pizzas. It's a very special night. Mine was salami and
Do you
pepperoni.
live with your brother?
Nice.
No.
Hey, you're
Brother?
vegan.
Oh, my mom actually lives in our basement, yes.
Uh-huh.
So technically I live with my mom.
What?
No, your mom lives with you.
Okay, but I like to say I live
Jinx.
with my mom.
No.
But it's my mom who lives in my basement instead of me who lives in
Do
my
you have a
mom's
big
basement.
house? Are you rich?
Okay, no.
Oh.
All right, so these are just, this bottom number is the total parts, number of equal parts in all. Okay, so out of the equal parts in all, they have to be equal too. So,
He threw his pen again.
Hey.
how many parts out of the total equal parts are shaded?
One.
Right, so 1 out of 4 parts are shaded.
Hey guys.
Mr. Flack.
So 1/4, right? So what fraction is not shaded?
3.
3 out of 4. So 3/4 not shaded. Okay, now this is important. You need to know not just the fraction, but what's left. The what's left concept is important. So, and not just with fractions. So if I ate 75% of the pizza, what percent is left?
25.
25%, right? So you just subtract it from 100. So if I ate 50/53 of the pizza, how much is left?
Oh, that's a big
3 53, right? So if I ate 50 out of the 53 pieces, how many are left? 3, okay?
I thought you said 51/3 of the pizza.
No.
And I was like, oh, this is
Okay, now here's the deal.
Sir, I'm afraid he sprayed me and threw a pin at me at the same time, and I call for uncalled mistreatedness.
Cruel and unusual punishment? I could be your defense attorney.
Yes, please.
Okay, so equivalent fractions. Anybody got a good definition of what equivalent fractions are?
No, they don't.
Yes, Nathan?
Like a definite. Well, like 1/8 and 2/16 are equivalent.
Okay, that's a good example.
Oh, yeah.
What's a good definition?
I mean,
okay.
Emerson?
Okay, so you can like round it down to like the smallest. So yeah. So that basically what Nathan was saying.
Like 2
I got a
2/16.
definition.
Yeah, 2/16 you can just like cut it in half to 1/8.
Okay, so like cut it in half is not really accurate, but I know what you mean by that. Okay? Because if you cut 2/16 in half, then you get like 2 30-seconds.
Okay.
So,
yeah,
or 1/16. Okay?
That's true.
Henry, you got a good definition?
Oh, I think so. So it's equivalent fractions are So maybe not the same numbers, but the same amount. So like
Okay,
one
that's a
half.
great way to say it. So it's the same amount, but different numbers of. So here's a good way to.
I got
I'm
one.
going.
Yeah, you got a good one.
If you simplify both numbers to the smallest, then they'll equal the same number by the end.
Yep. So if you reduce it, and it's the same amount. Okay. So here's the deal: same amount, but what makes it different is there's more parts. Same amount, but more parts. So think about a large pizza. I could cut that large pizza into 4 pieces. Which, by the way, pizza tastes better when they're bigger pizzas.
Yes.
Okay?
And
But-
there's someone else's pizza.
Yes. But that's not how it's done. How is it normally done? With a large pizza, how many pieces are there?
16.
There's sometimes there's 16, but most of the time there's about 8. Okay?
I once had a pizza that was 24 pieces.
So see how.
No, it was huge.
So here's that large pizza. If I ate 1/4 of the pizza and they were cut into 4 parts, that's what it would look like. But if I decided, well, I'm gonna share more, I guess I'm not gonna do that. So if you do that, see how 1/4, guys, see how 1/4 is 1 out of 4 pieces is the same thing as 2 out of 8.
Yeah.
Okay? So equivalent fractions, look at this. So it's still equal. They're still equal fractions. That's why there's that word equivalent, but the word equivalent has more parts in it. But see how you can see the word equal in there? So the word itself is equal with more parts. Okay? So same amount, equal, but more parts. Yes. Yes, Emerson.
Can I go to the restroom?
Great question. Yes.
Got it right, Emerson.
That is a great example of a horrible idea.
No.
Exactly.
You know Xavier?
I'm gonna use that, Xavier. That's a great thing because people think they're a great idea.
Funky trick.
Make sure you wear your mask.
Hey, safety first.
Okay, so the numerator and denominator of fraction can be multiplied or divided by the same number without changing the value. So here's what happens. Basically, we just doubled the number of pieces, right?
Yep.
So if we doubled the total number of pieces, we had to double this piece too. So basically, we cut everything in half. Cutting everything in half, so 1/4. Basically, we multiply the top and the bottom by 2 to get 2/8.
Wait.
Now I could have
Taught this
multiplied.
in 3rd grade, son.
I know. It's a good reminder.
Austin, you got a haircut.
Okay.
I like your cut, G.
All right. So, give me a fraction. Any fraction.
5/8.
5/8. So give me an equivalent fraction of 5/8.
10/16.
10/16. What'd you do?
I multiply both by 2.
Okay. Give me another equivalent fraction of 5/8. Ammo.
15, 20.
Oh,
Okay.
Mr.
What'd you
Flack.
do?
I
just
multiplied
multiply?
5 and 8 3 times to get that.
Okay.
I got a
That's
fancy
also
one.
an equivalent. What'd you get?
30/48.
30/48. So you multiply both the top and the bottom by 6.
Yeah.
Or 50/80ths. Or 500/800ths. Right?
Mr. Flack, you're not wearing
5,000,
your mask.
8,000.
I have one Mr. Flack.
Yes.
50th, 80th.
I have
I already
declared-
said that one.
I have-
Thanks for paying attention.
50th, 80th.
Okay.
45.
All right. So here's the deal, guys. All we're doing is multiplying fractions. Look at this. 1/4 times 2 halves. Well, what's 2 halves? What is 2 halves
That's
equal?
1.
2 8.
Right. So this is one big
Hey, don't trick
chubby
yourself.
1.
I am.
Okay. Well, this is just
Yeah.
multiplying by 2 over 2.
Hey, Emerson, let's not get hit in the face by one of those comedian trains here.
Go.
Okay. So guys, this is called the multiplicative identity property.
Whoa, big boy word.
What?
Big boy words. Whenever you multiply by 1, it maintains its identity. You can try that all day long. Whatever you see, just multiply it by 1 and see what happens.
So a lot of lesson,
Yeah,
a
nothing
lot of
happens,
lesson 14
Mr.
is
Flack.
equivalent fractions.
Watch this. Times 1. See how it didn't change?
Oh, dang.
It works. You can try it.
Yeah, I already know this. I learned this in all. I think it was.
So all we're doing, when we're multiplying the top and the bottom by the same number, when we're multiplying the top and the bottom by the same number, that's just multiplying by 1. Because the same number over itself equals 1.
Yep.
Okay? That's equivalent fractions. Now why is it important to write equivalent fractions? Why is that important? Why do we need to know how to do that?
Because sometimes you need like more precise thing, even though it's
Yeah, so you can do more precise by basically going the opposite way. If you can multiply the top and the bottom by the same number, that means you can divide. So what Nathan was referring to before is reducing, and what you were referring to is reducing a fraction. So reducing is kind of going the opposite. This is called expanding a fraction. Even though we're not changing the value of the fraction, we're just expanding it into more pieces, okay? So going the opposite way is called reducing. So if you can multiply both a top and number by 2, that means you can divide that answer both by 2, the top and the bottom, okay?
okay.
All right, so why else do we need to know how to use equivalent fractions? Nathan?
Because people could be arguing about, well, like something more important than pizza, like something that they, so one person had 4/8 and another had 1/2, and they don't know who ate more. You know
Yeah.
that they're equivalent.
Right, so if you have, so how do you know if they're equivalent?
Just divide by 2. If it's 4/8 first, you could divide
Okay.
1/2.
Let me ask you, what's more, 8/17 or 15/29?
Wait, say that again?
What's bigger? What's more pizza?
Oh, 8/17.
8/17 or 15/29?
Oh wait.
8/17.
8, 7.
No,
It's not.
15/29.
Okay,
Because the bigger fraction, if they're both -1 from half, like, you know what I mean?
yeah, so 8/17 is a little bit below a half,
Yeah.
right?
Mhm.
Because 8/6, so it'd be
8/16.
half of 17 would be 8.5. So 8/17 would be a little bit less than half. So, and then what was the other one? 15/29?
Yeah.
So 15/29 is a little bit more than half because 15 is half of 30, right? And half of 29 is 14.5, right?
Mhm.
So 15/29 is a little bit more than half. So that would be more. But the reason why that's, so when we compare fractions, it'd be easier if they had the same denominator, right? Then we could compare. Well, 3/8 is obviously less than 4/8, right?
Yep.
What's another reason we need to know how to make equivalent fractions?
Because we want to be smart.
What?
We want to be smart.
Why would you ever need to change a denominator?
To get equal denominators.
Yeah, why do you need
Common.
the same common denominators?
that you know stuff.
Okay, when do you need common denominators?
Walter.
Add it
What?
up.
When you add them, that's right. When you multiply, you don't need common denominators.
Oh, I
But-
remember how to do.
But when you add or subtract fractions, you need common denominators. So knowing how to make equivalent fractions is important. Okay? Let's scoot back a second.
You're so dumb.
So this is called expanding a fraction. Expanding. So now we're going to reduce. I want to reduce
Reducentation.
30/45. So that means 30/45. So that means I'm going to try to find something that I can divide out of both. Does anyone know? Michaela?
Turn around to the restaurant.
Yes. I thought you had it.
That was a great
No.
question.
Before you go, what can you divide out of both 30 and 45?
5.
5.
15 also.
So if I do divided by 5, divided by 5, then you get 6/9,
You
right?
could do 15.
You could not, and that's you actually divided out the greatest common factor.
That 2/3.
But we're looking for common factors, and then you can divide out of this. You can go another round, right? 6/9, there's something that can come out of both 6 and 9. 3, right?
Nice.
So then you get
Davis.
2/3, okay? But you could have just done the more harder thinking up front and figure out what the greatest common factor was.
More harder.
More harder?
More
Yeah.
harder.
That's a word. So you could have just divided by 15 and been done with it right away.
Yeah,
So that's 2/3.
my idea.
Okay? So that's, if you can figure out what the greatest common factor is, you can reduce the fraction in one step. All right?
That's coach. Oh, wait.
Sometimes that takes more work and more time to figure out what the greatest common factor is first and then divide it. Let's sit up, boys.
What are they doing?
Sitting up.
Sitting up, sit up in your chair.
Guys, you guys need
Sitting
to
up
go
in my
home.
chair.
Okay. So let's see if you can do that without me having to tell you that. Or we can have a discussion later, which you won't want to have. Okay?
Hey Ben, I just want
So
to
sometimes,
drink some water, okay Ben?
so sometimes it's easier to find the greatest common factor first and then divide it. Or maybe you don't have to do it that way. You don't have to reduce a fraction in one step like this. You could reduce a fraction in multiple steps as long as you get there. Now, the more steps you do, the more potential mistakes you might make. So just be careful of that. All right? So both of these ways is correct. There's not one way that's more important than the other or wrong. They're both right. Okay? So the magic question, when you're reducing a fraction, what are you asking yourself in your head?
What divides into both?
What goes into or what divides into both 30 and 45? Ideally, you want to ask what's the biggest thing that goes into both 30 and 45, but you don't have to. You can do it in multiple steps, and sometimes you don't have to think long, and it's just one step anyway. Like this 6/9, there's only one thing that goes into both 6 and 9. It's 3. So you divide 3 out of both of them, and you get 2/3. Okay? Do you guys have questions with this?
No.
Okay, so you guys know how to reduce fractions. You
Yeah.
feeling good?
Yep.
You know how to expand fractions.
Yep.
Will you
Go the
tell
opposite
the
way.
whole truth and nothing but the truth?
Yes, good job.
Black man, give me some math and I'll give you some flack. Black man.